Dive in. It'll be fine. All right, so example 4. This is solving a polynomial equation by factoring. So the premise that we're going to be doing here for these other type of equations is solve by factoring. Solve by factoring. So the idea in this particular section of your textbook is just let's look at a whole bunch of different types of functions. Let's look at all different types of setups, whether we have rational exponents, whether we have polynomials. Let's look at a whole bunch of different kinds, and we'll build some strategies for how we might go about solving these problems, okay? So all of these that we're going to look at today have to do with factoring. So for example 4, we have the problem. It says 5x to the 4th is equal to 80x squared. 5x to the 4th is equal to 80x squared. And our instructions in this case just say solve it. Solve it. So when we're solving an equation, we're trying to find what does x equal. When the function equals, what do we usually set it equal to? 0. We like for the function to equal 0 because when we're solving, we're finding solutions, or what's another word? Zeros, x-intercepts, roots. And so all of that takes place when the function is equal to 0. So in this case, if we want this function to equal 0, what are we going to do? Yeah, move that 80x squared over. When it crosses that highway, it crosses that equal sign, how does it become? So 5x to the 4th minus 80x squared equals 0. Anybody have any issues with that? Okay, so set it equal to 0. Look at it good. It's a quartic polynomial, means it has an x-fourth, the 4th degree. What are you thinking?
Factor out an x squared.
Sure. Factor out an x squared. What else could you factor out with the x squared? 5. So pull a GCF. 5x squared. When I divide 5x to the 4th by 5x squared, what's left? Minus, what are we going to have left over when we divide 80x squared by 5x squared? 80 divided by 5. 16? 16? 16? It's okay. They can't hear you on YouTube. You're fine. So we have 5x. Say it again. Okay, that's a difference of squares. What we have here is a product where the two terms multiplied by each other equal 0. So if we know that's the case, how do we solve for x? The zero product property says if the factors with the product equals 0, then one of the two factors. Yeah, now we're getting there. Set each piece equal to 0. So we might have 5x squared equals 0. We're going to solve for x. What's my move? Divide by 5 on both sides. So x squared equals 0. Square root it. X is equal to 0. Oh, man. I haven't been recording at all. Substitute a variable. I think this is where the wheels fell off, so we're going to probably be okay with this. Okay, so one step here, we're going to let new variable, what's a variable? A letter. Let the new variable equal the variable portion of the middle term. Let the new variable equal the variable portion of the middle term. Okay, we're going to get all the steps written down, And then I will tell you, we'll actually walk through one and it'll make a lot of sense. Okay. Number 2, we're going to rewrite the equation with the new variable. Rewrite the equation with the new variable. Number 3, we're going to factor and solve the equation with the new variable. Factor and solve the equation with the new variable. Okay. Number 4, we're going to substitute the old variable back in. Substitute the old variable back in. Number 5, solve the remaining equation. Solve the remaining equation. It's great. It's good stuff right here. You ever been to a dance? Anybody ever been to a dance? Really? No dances? None? Period?
Like a school dance?
Yeah, or a FFA dance or any kind of dance. Judson's been to a dance. Okay, Judson, we're banking on you to get this right, all right? You ready for this? What's the rule about going to a dance? You can change partners, right? You can dance with anybody. Everybody's friends at the dance. You can dance with whoever you want to. But say you take your girlfriend to the dance, right? Not that we know who it is. But imagine you take your girlfriend to the dance, right? And then at the dance, y'all all just have a good time. Everybody dances. We change partners. Life is good. At the end of the night, what's the rule? Like the cardinal rule, the rule that you don't break. You don't know. She gets the last dance. You're dang right. She gets the last dance, and what else? You better go home with the one that brung you. You can dance with a different partner all night long, but if you go home with somebody different, you got trouble. Do we agree? I mean, everybody knows this is the rule. We can switch, we can dance, everybody can have a good time, everybody's friendly. But if we go home with a different girl than we brought to the party, you're in trouble. Agreed? All right, so if you can go to a dance, you can do this math. It's going to be great. All right, so here's example 9. Are y'all ready? Example 9. Our instructions say solve. We've got 3x to the 4th power minus 2x squared minus 1 equals 0. 3x to the 4th minus 2x squared minus 1 equals 0. This is a quartic polynomial, just like the first example, just like number 4 that we did today. The difference in this one and number 4 is in number 4 there were only 2 terms. So we could factor out that x squared piece, and then we could operate it like it was a quadratic. This one has 3 terms. Can you see? Can you tell that the first term has a degree other than 2? Can you tell that the middle term has a degree that's half the size of the first one? That means this is in quadratic form. So we can use our substituted variable business. Okay? So pick a letter. J for Judson. The dancer. Pick a letter J. Okay? We're going to let the new letter equal the middle variable portion. Okay, so look at your second term there, the middle term. Do you see the variable portion of this middle term is x squared? So we're going to let J equal x squared. Okay. I coached basketball for a long time. And there would be situations when I need to get a player off the floor before she fouls out or before she causes me to say bad words. Right? I've got to sub her out. In order to sub her out, what do I have to do? Put someone else in, right? I can't just pull all of the x squareds out of this problem. I've got to put something in their place. I also don't leave any x squareds in the problem. That's the rule of substitution as well. If I'm going to put somebody in, I've got to take somebody out. Otherwise, I get a penalty and all kinds of stuff. So here, we're going to swap out all of the x squared stuff, and we're going to put in j in its place. X to the fourth is now going to be j squared. You have to see it as x squared squared. Right? It was x to the fourth. So how did I get x to the fourth? Well, I probably raised x squared to the second power. That's how I made x to the fourth. So that's why we're putting j squared in its place here. So 3j squared minus 2j. Remember, j is what we said was x squared. Minus 1. Now, why did we do that? Because now I've got a quadratic equation. I can factor it. Can you tell? I'm in the form of ax squared plus bx plus c. Okay. There is a coefficient of x squared. There is that little 3 in front. So if that's the case, we have to multiply a times c. So we'll have 3 times negative 1, which makes negative 3. We want factors of negative 3 that make negative 2. Negative 3 and 1. So now we're going to expand this function into those 4 terms we've talked about already today so that we can use grouping. 3j squared minus 3j plus 1j, or just j, minus 1 equals 0. Yep, drop your parentheses here, 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 here. Factor out something. What do we factor out? 3j. So what's left? J minus 1. And on the second set, can we factor anything out? So we put a 1 in front. Remember, if there's nothing to pull, we're going to have the 1 in front. So 3j plus 1 and j minus 1 equals 0. Okay, I like it. Now what? Set each one equal to 0. So 3j plus 1 equals 0. 3j equals negative 1. Divide by 3. We think j is equal to negative 1/3. I would agree with that. And out of my second sentence, j minus 1 equals 0. J equals 1. I like it. We put a box around it and go home?
No.
Wrong. We switch dance partners. If you go home right now, you're going to be in trouble. The girl gets the last dance, right? So we're going back to x squared. At this point, we've got j equal to negative 1/3. We're swapping j back out, and we're swapping x squared back in its place. X squared equals negative 1/3. And now we have to solve what's left. So it was a good move. It helped us solve the problem, but we're not done yet. Square root both sides, good. What happens when I square root that negative? I. So x is equal to plus or minus. Anytime I'm square rooting, I'm taking both the positive and negative. I square root 1/3. Good job. Nice work. And then our other solution, we had j equals 1. And we want to swap in x squared in place of j. So x squared equals 1. Square root both sides. Yeah, x equals plus or minus 1. How do we feel about that? Pretty smooth? Okay. Let's do the try it. The try it for this one's nice. All right, so here's the try it. We have x squared minus 8x squared. Sorry, x to the fourth. That first one's x to the fourth. X to the fourth minus 8x squared minus 9 equals 0. Okay, so a quick check. Are we in quadratic form? We have 3 terms. Is my first term something other than 2? X to the something? Is the second term x to the half power of the first one? Okay. Is the last term a constant? Then we're ready to go. So pick a letter. What letter? A. I heard A. A shall be the winner. So A is equal to x squared. So we're going to rewrite this equation with A instead of x squared. So now it's going to be what? A squared minus 8a minus 9 equals 0. Good. And then what? Yeah, we're going to factor it. We're factoring. Now we've got a quadratic equation that we can factor. Notice that in this case, there's no term in front of a squared. There's no number there. So we don't have to do a times c or this number times this number. We don't have to do that step. We can just say what are factors of negative 9 that make negative 8? Negative 9 and 1. So we have a minus 9 and a plus 1 equal to 0. Now, solve them both. Out of the first, what do we think? A equals 9 and a equals negative 1. We put a box around it and go home? No, we switch. So we said earlier a was x squared. So now we have x squared equals 9. Square root both sides. X must be plus or minus 3. And x squared equals negative 1. Good. X is equal to plus or minus I. Perfect. How many of these solutions would you actually see on the graph? On the graph? 2? You'd have to use your imagination to see the others? Because they're imaginary. Oh, that was punny. Good? Okay. 2 more. 2 more. And the last 2 are nice and smooth, especially after you get what we're doing on number 9. So here comes example 10. The problem says x plus 2 squared plus 11 times x plus 2 minus 12 equals 0. And that looks like a whole bunch of hullabaloo or something weird. Who even knows? You could distribute. You could factor out that x plus 2 and we could go from there. Or we could see that it's in quadratic form. Something squared plus b times something plus c. Can you see it? It's harder to see here, but they're in quadratic form as well. Bryson, what's your letter? J. No, not J. We already used J. K. D. What is D going to equal, Bryson? Okay. He's saying D equals, and we're setting that equal to what we have, x plus 2. So now we're going to rewrite our new equation. And this time, instead of x plus 2, we're using d. Now I have d squared plus 11d minus 12 equals 0. Ta-da! We made a quadratic equation. How can we solve it? Factor. Factors of negative 12 that make positive 11. Negative 1 and positive 12. So d plus 12 and d minus 1. So what does d equal? D equals negative 12 and positive 1. Last step. Sub back in x plus 2. Subtract 2 from both sides. I get x equals negative 14. And x equals, yeah. And I feel like that's a whole lot faster than expanding that first quadratic and then trying to simplify and combine like terms, and goodness gracious, that could get out of control. All right, so I'll give you a try it for this last one. Try it. And the problem says x minus 5 squared minus 4 times x minus 5 minus 21 equals 0. X minus 5 squared minus 4 times x minus 5 minus 21 equals 0. And the x minus 5s are in parentheses. You got it. You got it. Pick a variable. Uh-huh.
Oh.
Yeah, you got it. You got it. Twelve and 2. We get in the same place. Okay. There's one from your homework that I wanted to show you. Uh-oh. Pause. Show you guys really quickly. This is number 11. If you'll remember last week, I gave you an assignment and you did 6 through 12, and I told you don't do number 11, right? Because 11 falls into this category better than it did last week. So it says x to the 2/3 power minus 5x to the 1/3 power plus 6 is equal to 0. And it looks like we're dealing with rational exponents here. It looks like this goes with last week's lesson. But it's not. It's a quadratic form. There are 3 terms. The last term's a constant. The middle term is half the degree of the first. Can you see that? Okay. So in this case, it's much easier if we'll go about it the substitute variable route than if we try to do it like we did last week. Okay. So pick a letter. What letter you got?
B.
B. Sure. B is equal to x to the 1/3. So now how they got x to the 2/3 is they squared x to the 1/3, right? So this would be now b squared minus 5b plus 6 equal to 0. Factors of 6 that make negative 5. Ooh, positive 6. It's a positive 6, so they got to be the same sign.
X minus 3 and X minus 2.
Yeah, negative 3 and negative 2. Careful there. B minus 3, B minus 2. They've got to have the same sign because that's a positive 6. So B is 3 and B is 2. Now you have to swap back in your x to the 1/3. X to the 1/3 is 3. So how do I get x by itself? Raise it to the what?
Power of 3 over.
Yeah, to the reciprocal power, to the 3rd power. So x actually equals what's 3 cubed? 27. Not 3 times 3. 3 times itself 3 times. And then b equals 2. So x to the 1/3 is 2. Cube it. I'm hearing it over there. X is 8. Okay? That should help you with getting going on your homework.